Answer is 0 numbers are perfect squares. There is no number except perfect square from the series double one, triple one and so on. So answer is only one number, answer is 1. These 0 numbers from here, none of the numbers are perfect squares, because any perfect square ending with 1, tens place should be an even number. For 11, tens place is an odd number. 111, tens place is an odd number. 11, 111 and so on. All these are eliminated. Only number which is a perfect square is 1. I hope the idea is clear. Method 1. Method 2. Method 2. Any perfect square is of the form. Any perfect square will be of the form either 4 into something or 4 into something plus 1. Every perfect square should be of the form 4p plus 1. Suppose if I take from 11, 111, 4 ones, you take from all this case, what are the last 2 digits of that number? Last 2 digits of a number is 11. 11 is nothing but 4 into 2 plus 3. 4k plus 3 does not arise for perfect square. Answer for this question is 1. I hope the logic is extremely clear to you. Either you can go by the tens digit unit digit logic, or you can go by the perfect square form. A perfect square is always of the form 4 into something or 4 into something plus 1. Method 1, method 2. Depending upon your observation, you can take any that thing that is possible. Next one, how many numbers are of the form 1, 1, 2, 3, 1 and so on up to the last number is 1, 2, 3, 4, 5, 6, 7, 8. How many numbers in this series? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. These 1, next is 1, 2, next is 1, 2, 3, next is 1, 2, 3, 4, next is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Multiple logics we will use. What is the first logic? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. All these 4 cases are out. Any perfect square ending with 4, tens place should be an even number. 8 square 64, 12 square 144, 18 square 324. Tens place is an odd number. Any perfect square ending with 5, tens place is always 2. 5 square 25, 15 square 225. Any perfect square ending with 6. Any perfect square ending with 6. 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. We have to check whether this number is a perfect square or not. Now see here. 1, 2, 3, 4, 5, 6. Now if you observe this question, it is ending with 6. So 56 is also divisible by 4. Digital sum also 6 plus 3, 9, 5 plus 4, 9, 2 plus 1, 3. So perfect, it is giving you digital sum how much? Digital sum 3. What is the perfect square logic? A perfect square digital sum should always be, a perfect square digital sum is always 1, 4, 7 or 9. But according to the question, what is the digital sum we got? 3. So these cancelled. So the only number which is a perfect square is nothing but 1. Very simple example which explains multiple concepts. A perfect square never ends with 2, 3, 7 or 8. Depending upon the unit digit, tens place will be there. Already we discussed one beautiful logic. A perfect square tens place is odd number only when the unit digit is 6. Only when the unit digit is 6, tens place is an odd number. This logic I used. A perfect square digital sum is 1, 4, 7 or 9. I hope second problem is also clear to you. Third one. Another one. How many numbers are of the form 4, 44, 444 and so on? Suppose if I take 4 common, these are nothing but 1, 11, 111, these are nothing but and so on. All this. In this one, all these numbers starting from the second number are of the form 4p plus 3. A perfect square will never be of the form 4p plus 3. So answer is only one number and the number is nothing but the first number. Answer is 4. I hope the logic is clear. A perfect square will never be of the form. A perfect square will never be of the form 4p plus 2 or 4p plus 3. Each and every question are created out of a lot of research and to make a student absolutely understand the beauty of this concept. If you miss any of these classes, right, show whatever I am sharing these logics with your friend, probably in your coaching center, in your, right, any of the online classes, this concept is not taught. Most of the concepts that are taught are nothing but the problems taken from the books, right, and most are rote based learning. I hope it is clear. Next one. How many 5-digit perfect squares that can be formed using the digits 1, 2, 3, 4, 5? There are 5 digits. 1, 2, 3, 4, 5. Each digit is used exactly once. Each digit is used exactly once means repetition of digits is not allowed. Repetition of digits is not allowed. When you are using 5 digits in a 5-digit number exactly once, that means repetition of digits is not allowed. Repetition of digits is not allowed. So one number could be of the form 1, 2, 3, 4, 5. Next number could be of the form 2, 5, 4, 3, 1. Next number could be of the form 5, 4, 1, 2, 3 and so on. Are you all with me? 1, 2, 3, 4, 5, 2, 5, 4, 3, 1, 5, 4, 1, 2, 3 and so on. Now if you see the digital sum of these number, digital sum of these number is nothing but, even in whatever the order that you do it, digital sum will not change. So summation 5. Summation 5. Summation 5 is nothing but 1 plus 2 plus 3 plus 4 plus 5. Summation 15. 15 is nothing but digital sum 6. Digital sum 6. So all the 120 numbers that are formed, what are the 120 numbers? 5 numbers arranged in 5 places, it is 5 factorial, which is 120. All the 120 digit numbers, irrespective of the order in which the digits are written, sum of the digits is always 6. A perfect square digital sum will be 1, 4, 7 or 9. So answer for the question is 0. Answer for this question is 0. I hope the idea is clear. Sum of the digits is 15. 15 is 6. For a number to be a perfect square, its digital sum should be 1, 4, 7 or 9. Idea clear? Now another question. How many 3-digit numbers ABC will satisfy the condition ABC equivalent to A cube plus B cube plus C cube? This is nothing but an Armstrong number. This is nothing but an Armstrong number, one of the very few numbers where you started doing your initial numbers. There are, right, 153 is one such Armstrong number, 307 is one such Armstrong number, 317 is another Armstrong number, 407 is another Armstrong number. If you see, these are nothing but 1 cube plus 5 cube plus 3 cube. 125 plus 27, 152 plus 1, 153. 3 cube plus 0 cube plus 7 cube. 343 plus 27 is 370. Sorry. 371. 371. I wrote a mistake here. It is 371. It is 371. 370. Next is 371. 3 cube plus 7 cube plus 1 cube. These also nothing but 4 cube plus 0 cube plus 7 cube. 343 plus 64, which is nothing but 407. In a 2-digit numbers, there are 4 such Armstrong numbers, 153, 370, 371 and 407. Like that in a 5-digit number, 6-digit number, there are some numbers 655053. Like that there are so many Armstrong numbers that are there. Now these are the 4 such numbers which will satisfy. Instead of doing 4 different values, I will show you how 153 is obtained for one such value. Same process you can find it out. You will get 370, 371, 407 also. Now proof. why 153 is coming out to be 1 cube plus 5 cube plus 3 cube. I will prove this. I will prove this so that the same pattern can also be followed by 370, 371 and 407. Now see here, ABC is a 3-digit number. If ABC is a 3-digit number, C is there in units place, B is there in tens place, A is there in hundreds place. Hundred A plus 10B plus C equivalent to A cube plus B cube plus C cube. Let me take A value 1. If I take A value 1, 100 plus 10B plus C equivalent to 1 plus B cube plus C cube. So this is nothing but B cube plus C cube equivalent to 99 plus 10B plus C. I hope this equation is clear. B cube plus C cube is 99 plus 10B plus C. Now, B cube plus C cube minimum value. B cube plus C cube minimum value will be when B is 0 and C is 0. That is 99. B cube plus C cube maximum value is when B equivalent to 9, C equivalent to 9, which is 198. 198. Listen carefully, sir. B cube plus C cube minimum value is when B is 0, C is 0. B cube plus C cube should start from 99. Should end at 99 because the maximum digit B and C can take is 1. From this equation, I can say that B and C will definitely be less than 6. Because if I take 6 cube plus something, 216 plus something cannot be 198. B value cannot be 6. So let me take B value 5. If I take B value 5, what will be the equation will become? So this will become 5 cube plus 6C cube equivalent to 99 plus 50 plus C. C cube minus C is nothing but 99 plus 50, 149, 149 minus 25, 24. So these is nothing but C into C square minus 1 is C into C minus 1 into C plus 1 is 24. C is 3. Because 3 into 2 into 4 is 24. A value 1 we got, B value 5 we got, C value 3 we got. So the number is nothing but 153. Are you all with me? Similarly, try it out for A value 2. Similarly, try it out for A value 3. Like that, you will get cases. There are 4 different values, means there are 4 different equations that you have to do it. The only thing you have to do it is for A value 1, 2, 3, 4 and 5, you have to do it. I hope this equation is clear. There are 4 numbers that will satisfy, which are called as an Armstrong number: 153, 370, 371 and 470. These are the 4 Armstrong numbers which will satisfy this property ABC equivalent to A cube plus B cube plus C cube. Very, very good question. One of the first few C programs which you will write when you enter into the first year of engineering. Next one, another good question. Find the smallest positive integer. I want the smallest positive integer. N greater than or equivalent to 2. 2 square minus 1. 2 square minus 1 is nothing but 2 minus 1 into 2 plus 1, which is nothing but 1 into 3. 3 square minus 1. 3 square minus 1 is nothing but 3 minus 1 into 3 plus 1, which is again nothing but 2 into 4. 4 square minus 1. 4 square minus 1 is nothing but 4 minus 1 into 4 plus 1, which is 3 into 5. Next one, 5 square minus 1. 5 square minus 1 is nothing but 5 minus 1 into 5 plus 1, which is nothing but 4 into 6. That means if you observe, 3 is becoming 3 square, 4 is becoming 4 square, 5 will become 5 square. So n square minus 1, which is nothing but n minus 1 into n plus 1. If n is there, previous number will become n minus 1 square minus 1. So which is n minus 2 and n. So all the numbers, if you observe, all the numbers, first two are remaining and last two will be remaining, n minus 2 into n. So the last it will be n minus 1 into n, remaining all will have a squares. 3 into 3 is 3 square, 4 into 4 is 4 square, 5 into 5 is 5 square, like that. So what will be remaining is 1 into 2 into 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square. First two and last two. First two, n minus 1, n plus 1. n minus 1, n plus 1. First two and the last two will be remaining. These two and these two will be remaining. So n into n plus 1, this is nothing but a perfect square, which is k square. So 2n into n plus 1 into all these 3 square, 4 square, 5 square and so on, that is nothing but another perfect square equivalent to k square. This is a perfect square, this is a perfect square. So this should be a perfect square. For it to be a perfect square, already 1, 2 is there. So extra 2 if I keep 2 into 2 into 3, which is not a perfect square. So 1, 2 is there. Power of 2 should be an even number to get a perfect square. If I take 2 cube, so these is nothing but 2 into 8 into 9. 72 2s are 144. 144 is a perfect square. So the value, smallest value that will make these term perfect square is n is 8. It is a simple calculation problem. 1 into 3, 2 into 4, 3 into 5. If you observe, 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square and so on. So only the first two and the last two will be there. Only the first two and the last two will be there. See, simple thing what you can do is, you take for 3 numbers, you will understand why the first and last are only there. If you observe, first two and the last two, 3 into 3, 3 square, 4 is also a perfect square. You can take smaller values and check it out how many different values are there. It's a very, very good question. Most of the questions are relatively new question. Please practice good conceptual content. Practice less number of problems but variety of problems rather than practicing one variety of problems 100 times. I hope it is clear. Next one. Another beautiful question, sir. Please take 1 minute to read the question. Take 1 minute to read the question. Read the question first. A is a 3-digit number. ABC is a 3-digit number. ABC is a 3-digit number. ABC is a 3-digit number. If you strike out the leftmost digit of A, leftmost digit is A. If I strike it out, BC is a perfect square. BC is a perfect square. Okay. What are the 2-digit perfect square? 3 square is 0, 9. It is 4 square, 5 square, 6 square, 7 square, 8 square and 9 square. Are you all with me? BC is a perfect square. What is another? If you strike the extreme rightmost, see, if I delete, AB is a perfect square. AB is a perfect square. That means if I strike 6, remaining number should be a perfect square. What is the nature of a perfect square ending with 1? Tens place should be even. So 81 is perfect square. This perfectly shooting. If I strike out 5, this number will end with 2. A perfect square never ends with 2, 3, 7 or 8. If I strike out 6, it will end with 3. A perfect square never ends with 3. A perfect square ending with 9. What is the nature of a perfect square ending with 4? Tens place should be an even number. 0, 4. 0, 4 will become a 2-digit number. 24. 24 is not a perfect square. 44 is not a perfect square. 64 is a perfect square. So if I remove 6, 49 is a perfect square. If I remove 9, 64 is a perfect square. Are you all with me? If it is 1, tens place will become 8. A perfect square never ends with 2, 3, 7 or 8. If it is 4, any perfect square ending with 6, tens place should be an even number. So it can be 1 or it can be 3. 16 is a perfect square, 364 is a perfect square. How many numbers we got? 816 we got one number, 164 we got one number, 364 we got one number, 649 we got another number. If you observe the beauty about this question, 816, you remove leftmost, 16 is a perfect square, 64 is a perfect square, 64 is a perfect square, 49 is a perfect square. Here 64 is a perfect square, 36 is a perfect square, 16 is a perfect square, 81 is a perfect square. How many such numbers are there? 4 numbers are there. All the questions whatever we are discussing today are nothing but a perfect square. You will start wondering, from a small concept in number system, this many questions can be developed. Yes, the answer is yes. After this class, you will never feel like listening to anyone's class in terms of the concepts. I can vouch for it. I can say it with experiential authority and the kind of research I have done in the world of mathematics. Right? Every possible question I kept it here. ABC. BC is a perfect square. I hope it is clear. There is a 3-digit number. Remove leftmost, remaining 2 will be a perfect square. Remove rightmost, remaining 2 will be a perfect square. 4 such numbers I got. Next one. If x and y are integers, very good question, sir. If x and y are integers in the range 1, 40, if there is a rectangular number box, that means it is including 1 and 40. Including 1 and 40. If the box is like this, open bracket, closed bracket, it is like this, that means excluding 1 and 40. Excluding 1 and 40. Including 1 and 40. How many pairs of x comma y? Is x comma y a perfect square? X comma y should be a perfect square. X comma y should be a perfect square. This expression x comma y will be a perfect square under 2 cases. Any perfect square power should be an even number. Power should be an even number. How many even numbers are there? 20 even numbers are there. From 40 numbers, 20 are even, 20 are odd. X can take any value from 1 to 40. So total 40 values are there. Are you all with me? So if it is for 1 square is 1 value. 1 square. Are you all with me? So 40. 40 into 20. 800. 40 into 20. Are you all with me, sir? 40 into 20. X can take any value. X can take any value. Here please observe what are that values that I am taking. 1 square, 1 power 4, 1 power 6 and so on up to 1 power 40. Next is 2. 2 square, 2 power 4, 2 power 6 and so on up to 2 power 40. Are you all with me? If it is 40, 40 square, 40 power 4 and so on up to 40 power 40. Yes or no? Perfect square means power will be an even number. So each value, each from 2 to 40, 20, like that 40 numbers are there. 40 into 20, 800. In this one, 19 values will give a same number. 800 minus 19 is 781. 781. Are you all with me? This is only case number 1. Right? I think he has not. X and y are distinct numbers. How many pairs is x comma y? How many pairs only is asking, right? How many values he is not asking. So here, I hope you have understood what am I doing. 40 into 20 is 800. He is not asking you the distinct values for x comma y, because how many pairs? 1 square is 1 pair, 1 power 4 is another pair, 1 power 6 is another pair, 1 power 40 is another pair. You cannot write 1 power 4, 1 power 6, all they are giving one value, but the question is how many values x comma y will take. So it is 800. I hope it is clear. What is this case 1? Case 1, x comma y is a perfect square when y is an even number. When y is an even number and x is a x could be an any number. Perfect square means power should be an even number. Case 1 clear. Case 2. Case 2. One more case also I will get it. This is the case where most of the students will miss it. X comma y is a perfect square What is the next case that will miss it? Case 2. Case 2 is y can be an odd number. Y can be an odd number and x can be a perfect square. All these will also give x comma y a perfect square. So 1 square, 2 square, 3 square and so on up to 6 square. Are you all with me? Because I cannot take 7 square 49. Range is from 1 to 40. So 1 square power 1. 2 square, 1 square power 3. Are you all with me? 1 square power 1. 2 square power 1. 2 square power 1. 2 square power 3. 2 square power 5. 2 square power 7 and so on. So odd number, how many values are there? Total 20 odd numbers are there. Perfect squares means total 6 numbers are there. Because what is the perfect square less than 40? 6 square is 36, 36 is less than 40. So 20 into 6, 120 combinations. Previously I got 800, now I will get 120. So the total answer is 920. Total answer is 920. Most of the students will tick mark the answer as 800, which is incorrect. For a power x power y to be a perfect square, there are two cases. Y could be an even number or y could be an odd number. If y is an even number, the base could take any value. If y is an odd number, the base could take only perfect squares. The only perfect squares. Extremely important, sir. If it is of the form x power y could be an even number or y could be a perfect square. Y could be a odd number. If y is an odd number, x will be a perfect square. Here x could be any integer. This is a very important observation. I have seen a lot of students doing mistake in this question because till now we discussed that a perfect square power will be only be an odd even number. A perfect square can also have power an odd number and the base as a perfect square. Are you all with me? Base can be a perfect square, power can be an odd number. Base could be anything but the power can be an even number. Extremely important questions, sir. Quality questions. Next one. The sum of 4 consecutive 2-digit odd numbers. 2-digit odd numbers. Odd numbers will have odd unit digit. Odd numbers will have odd unit digit. What are the unit digits possible for an odd number? 1, 3, 5, 7. Yes or no? 31, 33, 35, 37. It can also be 3, 5, 7, 9. 33, 35, 37, 39. 5, 7, 9, 1. 45, 47, 49, 51. 77, 79, 81, 83. 19, 21, 23, 25. Yes or no? These are all the possible 4-digit unit digits. 1, 3, 4, 7. He said sum of 4 consecutive 2-digit odd numbers. 11, 13, 15, 17, they are an odd numbers. 13, 15, 17, 19, they are also an odd numbers. 15, 17, 19, 21, these are also an odd numbers. 27, 29, 31, 33, these are also an odd numbers. So these are the 5 ways. But he said something. Sum of 4 consecutive 2-digit odd numbers when divided by 10. When you divide a number by 10, unit digit should be 0. When you divide a number by 10, unit digit should be 0. Let us see. 7 plus 5, 12, 15, 16. Unit digit is not 0. 16, 21, 24. Unit digit not 0. 12, 21, 22. Unit digit not 0. 16, 17, 20. Unit digit 0. 9, 1, 3, 5. Unit digit is 8, not 0. So that means 7913. 7913. Now if you plug in an answer option, easily you get it. Answer becomes a perfect square. What is the first option? 21. So if you plug in this value, if this is 21, this is 23, this is 17, this is 19. 17 plus 19, 36, 36 plus 44. 80. 80 is not a perfect square. 25. If it is 25, 25 case is not possible because the unit digit should be 7913. If I take 41, 41, 43, 37, 39, 76 plus 84, 160. 160 when divided by 10, 16. 16 is a perfect square. Beautiful question which explains you, right, how to remove the incorrect values just based on condition. First he gave there are 4 consecutive 2-digit odd numbers. He said then it becomes divided by 10. Then the answer when divided by 10 it is a perfect square. 1357 one value. 3571. It could be it is not necessarily starting with 1. It could be 1357, it could be 3579, it could be 5791, it could be 7913, it could be 9135. Because it is divided by 10, unit digit should be 0. Unit digit 0 is possible in only one case, that is 7913. Idea clear? Idea clear, right? 41. Another question. From all natural numbers, there are natural numbers from 2 to 10,000, okay? First, all the perfect squares are erased. That means there is a round 1. In round 1, perfect squares are erased. 2 square, 4 is erased. 9 is erased. 16 is erased. All the perfect squares are erased. Okay, clear? Then all the perfect cubes are erased. Then all the perfect cubes are erased. 2 cube, 3 cube, 4 cube and so on. Clear? Then all the perfect fourth powers are erased. Fourth powers are erased. See, I cannot take 2 power 4 because 2 power 4, this case already came in round 1. Fourth power is nothing but the second power, right? At least one number is erased in them. Round 1, all the perfect squares are erased. Round 2, all the perfect cubes are erased. In round 3, you cannot erase fourth powers because fourth powers are already erased. Fourth power is nothing but the square of the square power. 2 power 4 already came it as 4 square. That means in round 3, instead of doing fourth power, I will do the fifth power. 2 power 5, 3 power 5, 4 power 5 and so on. Idea clear? Next in round 4, I cannot do 6th power. 6th power is nothing but the square of the cube power. 6th power is nothing but the square of the cube power. So 6th power I will not do. 7th power I will do. Are you all with me? 6th power. 2 power 6 is nothing but 8 square. Right? 2 power 4 is nothing but 4 square. I hope you are understanding why we are eliminating 4th powers and 6th powers. Round 5. 8th power I cannot do it. 8th is nothing but a power 4 whole square. 8th is nothing but 2 power 4 power 2. 8 comes in 2. 8 comes in 2. 9 comes in 3. 10 comes in 5. 11 will not come. So only the prime powers I am eliminating. I hope the logic are clear. Prime powers I am eliminating. Prime powers I am eliminating. So 2 power 11 will become, 2 power 10 is 1024. 2 power 11 will become 2048. So round 12, 6. 2 power 12 cannot be eliminated. 12 is nothing but it is already eliminated in square and square power or in power 3. Round 6. 2 power 13. 2 power 13 is nothing but 8 into 1024, which is less than 10,000. I need to stop here because the maximum upper limit a value can take is 10,000. So at least one numbers are erased in how many? 1, 1st, 2nd, 3rd, 4th, 5th, 6th. Answer is 6. Are you all with me? By default, what the mistake most of the students will do it is, they will take 2 power 4, they will take 2 power 6, they will take 2 power 8. Answer is nothing but the prime powers. The answer is nothing but the prime powers. What are the prime? What is the 2 power n? Because it is starting from 2. 2 power n. 2 power n. 2 power n is nothing but 2 power n is nothing but less than 10,000. 2 power n is nothing but less than 10,000. I hope the idea is clear. Please look into each and every question of mine. Each and every question is a quality question. M and n are two positive integers that satisfy the equation n cube plus 2n square equivalent to m square. 1 less than or equivalent to n less than or equivalent to 1000. This is nothing but n square into n plus 2 is nothing but m square. N square is a perfect square. N square is a perfect square. M square is also a perfect square. M square is also a perfect square. So this should be a perfect square. This should be a perfect square. N plus 2. I cannot take 1 square because n will be negative. N is a positive integer. 2 square, 3 square, 4 square and so on up to. Write 1000. 1000 means 31 square is 961. 32 square is 1024. From 2 to 31, total 30 values are there. Total 30 values are there. N cube plus 2n square equivalent to m square. So n square into n plus 2 is m square. N square is a perfect square. M square is also a perfect square. N plus 2 should be a perfect square. For n plus 2 should be a perfect square. N plus 2 can take any value from 2 square to 31 square because the upper limit that is given in the question is 1000. 31 square is 961. 31 square is 961. I hope the idea is clear. I cannot take 1 because n plus 2 1 square n value will become negative. N is a positive integer. N is a positive integer. I hope the idea is clear. Next one. Find the prime number p such that 71p plus 1 is a perfect square. 71 plus 1 is nothing but a perfect square. Perfect square is of the form k square. So k square minus 1 is nothing but 71p. These are nothing but k minus 1 into k plus 1 equivalent to 71p. The catch in the question is p is a prime number. A prime number cannot be decomposed further. So only two cases I will get 71 into p or p into 71. Are you all with me? So that means if k minus 1 is 71, k will become 72 and k plus 1 is equivalent to p, p will become 73. 73 is a prime number. 73 is a prime number. So this case it is possible. Suppose if I take the next case, k minus 1p, k plus 1 is nothing but 71. K value is nothing but 70. 70 minus 1 is 69. 70 minus 1 is 69. 69 cannot be a prime number. So the only case that is possible is p value is 73. Beautiful question, sir. The condition in the question is p is a prime number. 71p plus 1 is k square. K square minus 1 is 71p. K minus 1 into k plus 1 is 71p. P is a prime number. So it cannot be decomposed further. 71 into p or p into 71. K minus 1 71, k is 72. K plus 1 p. K value 72 means 72 plus 1 is 73. Idea clear, right? Second case is not giving you p as a prime number. A good question based upon the definition of a prime number. Next one. Find all the positive integers n for which 2 power m plus 2 power 7 plus 2 power n is a perfect square. Mistake. Most of the students will do this mistake first. What is the mistake we will see? A plus b whole square is a square plus 2ab plus b square. So these is nothing but 2 square whole square. These 2 into 2 square. 2 cube. Next is 2 power 4. So they will write 2 power 4 whole square. So this is nothing but 2 power 4 plus 2 power 7 plus 2 power 8. Please check whether this number is giving you perfect square. Check it out. 16 plus 128 plus 256. 256 plus 16 is 272. 272 plus 128, which is 400. 400 is nothing but a 20 square. Are you with me? So 2 power 4 is 16 plus 128 plus 256. 256 plus 16, it is 272 plus 128, 400, 20 square. Always remember, whenever you are doing, the sum should be a perfect square. If the sum is a perfect square, if you are getting perfect square, then this approach is right. If the sum is not giving you perfect square, after doing this, please check whether the sum is a perfect square. If the sum is not a perfect square, then you are in a danger zone. Are you all with me? To avoid this danger zone, let us do a method 2 approach. Method 1, I hope it is clear. A plus b whole square is a square plus 2ab plus b square. So 2 power 4 plus 2 power 7 plus 2 power 8. 2 power 8, 256, 128, 16. I am getting 400, which is a perfect square. There is also another approach to solve this question. That is 2 power 4 plus 2 power 7 plus 2 power n. It is a perfect square. 144 plus 2 power n, which is nothing but k square. K square minus 144 is nothing but 2 power n. This is nothing but k minus 12 into k plus 12. It is nothing but 2 power n. Listen carefully, sir. Listen carefully. What is the difference between these two numbers? Difference between these two numbers is 24. K plus 12 minus of k minus 12. 24. Let us see where is the difference. 24. 2 power 1 is 2. 2 square is 4. 2 cube is 8. 2 power 4 is 16. 2 power 5 is 32. What is 32 minus 8? 24 I am getting. Are you all with me? So this can be 2 cube and this can be 2 power 5. So k minus 12 can be 8. That means k value 20. Or k plus 12 is 32. K value 20. There also in the previous case we got k value 20. I hope it is clear. Add the values and check whether the number is a perfect square or not. Most likely it will be a perfect square, just for our safeguarding our calculation and the values, and checking whether are there any more values. That first method has given you directly one value. Directly only one value it has given. There could be a chances of getting, for example I gave a question. Suppose for example, if the difference is 4, why I said the previous method may not be the best method is, suppose for example, if the right hand side is, if this is 4, there could be a case 6 minus 2 is 4, or there could be a case 8 minus 4 is 4. Are you all with me? Are you all with me? There could be a possibility of more than one case where the powers of 2 difference can also be there. So please cross check it once again. Always I advise you to go with method 2. Method 2. I hope the idea is clear, right? Next one. Find all the integers for which the quantity n square plus 19n plus 92 is a perfect square. N square plus 19n plus 92, it is a perfect square. I will multiply with 4. I will tell you why am I multiplying. 4n square plus 17n plus 368 equivalent to k square. Can I write it as like this? 2n plus 19 whole square. 2n whole square is 4n square. 2 into 2n, 4n into 19 is 76 plus 7 equivalent to k square. This is nothing but k square minus of 2n plus 19 whole square equivalent to 7. So these k plus 2n plus 19 and k minus 2n minus 19. 7 is nothing but a prime number. You can write it as 7 into 1. So if I add it, k plus 2n plus 19 is 7. K minus 2n minus 19 is 1. So 2k is nothing but 8. K value is nothing but 4. I hope it is clear, right? Clear? If I substitute 4 here, this equation will become n square plus 19n. 4 square is nothing but 16. So it is nothing but 16, 92. 92. K square, where is the mistake? So 2k. Okay, I think what we did is, it is 4k square. It is 2k square. It is 2k. It is 2k. It is 2k. Are you all with me? It is 2k. It is 2k. It is 2 into 2k. It is 2 into k. So k value is 2. If k value is 2, so n square plus 19 n plus 88 equivalent to 0. So I got minus 11 and minus 8. Minus 11 and minus 8. N value is minus 11 and minus 8. So I got two values. Please ensure that here I am adding 4k square. It is nothing but 2k whole square. It is nothing but 2k whole square. Why am I adding, multiplying by 4? Because I want to get it in the form of a plus b whole square. Otherwise, I have to do n plus 19 by 2 whole square and everything. That many complication, I don't want to do it. Avoid silly mistake. A very, very good question to check how many quadratic expressions can take a perfect square or not. Idea clear, right? Minus 11, minus 8. Another question. Now, if you see this question, find all the integer for which the quantity n square plus 96 is a perfect square. N square plus 96 should be a perfect square. Most of the students, what they do is, they will keep factorizing it. K square minus n square equivalent to 96. I will stop it here. K square minus n square is k plus n into k minus n equivalent to 96. I will stop it here. I want to discuss a very, very important logic. X square minus y square equivalent to k. This equation has integral solutions. This equation has integral solutions only if k is an odd number and k is a multiple of 4. X square minus y square has integral solutions only if k is an odd number and k is a multiple of 4. So x square minus y square is nothing but x plus y into x minus y equivalent to k. X is an even number, y is an even number. Even number plus even number, even number. Even number minus even number, even number. X is odd, y is odd. Odd plus odd, even. Odd minus odd, even. First two cases. X is even, y is odd. X is odd, y is even. If I take the first two cases, x is even, y is even. Even plus even, even. Even minus even, even. That means k is divisible by 4. X is odd, y is odd. Odd plus odd even, odd minus odd even. That means it is also divisible by 4. That means if the right hand side is a multiple of 4, what is the conclusion? X plus y should be an even number. X minus y should be an even number. If you take these two cases, even plus even, even, even minus even, even. Odd plus odd even, odd minus odd even. X plus y even, x minus y even. If x plus y even number, so these 2x. X minus y even number, 2y equivalent to 96. X into y is nothing but 24. Can I say k plus n is greater than k minus n? Sum of two natural numbers is always greater than their difference. So k plus n, and so we will write all the factors. 24 into 1. That means x is greater than y. 12 into 2. Next is 8 into 3. Next is 6 into 4. There is no other way we can write. 1 into 24, if I write, y will be greater than x, but x is greater than y. So how many cases we got? We got total 4 integral solutions for this equation. Because the right hand side is given as 96, which is a multiple of 4, I solved it in this way. Are you with me? If k is a multiple of 4, if k will be a multiple of 4, if x plus y is an even number, x minus y is also an even number. Any even number is of the form 2x multiple of 2. I hope this logic is clear. Don't keep on factorizing 96, 1 into 96, 2 into 48. Do it like this. I hope this question is clear to you. How many 3-digit numbers on cubing will give 44 as last 2 digits? There is a question on cubing. First we will discuss the concept. X cube and 50 plus x whole cube has the same last 2 digits. If x is even. Very good concept, sir. X cube and 50 plus x whole cube has same last 2 digits if x is even. Proof. Listen carefully, sir. None of these concepts you will find in anywhere in the other YouTube videos. You have to come and sit and listen to my concept. Suppose 123. Last 2 digits of a number is 23. Last 2 digits of a number is 23. So last 2 digits of a number, it is nothing but remainder when you divide a number by 100. Last 2 digits of any number is when you divide a number by 100. If I expand this bracket, a plus b whole cube, a cube, next is 3a square b, next is 3ab square, and next is b cube. These divisible by 100, x is an even number. Even number square means it is divisible by 4. These also divisible by 100. What is remaining? X cube. Extremely important key point. X cube 50 plus x whole cube has same last 2 digits if x is even. X cube 50 plus x whole cube has same last 2 digits only if x is even. If x is an even number, x cube 50 plus x whole cube has same last 2 digits. This is concept 1. Second concept. I hope the idea is clear. Second concept. Concept 2. Concept 2. Very important logic. A perfect square. This is something which we already discussed. A perfect square never ends with 2, 3, 7 or 8. This is something which you already know. A perfect square never ends with 2, 3, 7 or 8. But from here, if I take the unit digit of a number, unit digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A perfect square never ends with 2, 3, 7 or 8. Pick the numbers which are 7, 2, 3, 7 or 8. On cube only I am getting a different number. 0 cube is 0, 1 cube is 1, 4 cube is 4, 5 cube is 5, 6 cube is 216, 9 cube is 729. Remaining all the numbers are nothing but the 10 minus unit digit. 2 cube is 8, 10 minus 3 it is 7, it is 3, 8 cube is 512. A perfect square never ends with 2, 3, 7 or 8. Only these 2, 3, 7 or 8 on unit digit. If I cube it, I am getting the unit digit which is the tens complement of the unit digit. 0 cube 0, 1 cube 1, 4 cube 4, 5 cube 5, 6 cube 6, 9. Or you can write like this. A perfect square never ends with 2, 3, 7 or 8. If I cube it, I will get 2, 3, 7 or 8 in the reverse order. 8, 7, 3 or 2. Are you all with me? 2, 3, 7 or 8 on cube is nothing but 8, 7, 3 or 2. X cube 50 plus x whole cube has same last 2 digits if x is even. First point. Second point is a perfect square never ends with 2, 3, 7 or 8. 2, 3, 7 or 8 on cube I will get another unit digit 8, 7, 3 or 2. 8, 7, 3 or 2. Idea clear? With this, we will solve this question. Once you understand this concept, it is very clear. How many 3-digit numbers If you see your regular textbook, there will be an half page or a full page proof. I will make it into a straightforward seconds answer if you know this logic. ABC whole cube, it is ending with 44. If it is ending with 4, this will be 4. Yes or no? Just now we discussed 4 cube is 64. 14 cube is nothing but 2744. 4 cube is 64. What will be the next number? 64. How many 3-digit numbers? So it can be 114, 214, 314, 414. It can be 164, 264, 364 and 464. Are you all with me? How many 3-digit numbers? Till 3-digit numbers means it is still 914. It is still 964. 9 plus 9, 18. Single. Straightforward answer if you know the logic. ABC on cubing, I got 44 as the last 2 digits. C is nothing but 4. 4 cube is 64. Next number is 14. 14 cube is 2744. Last 2 digits is 44. Next number will become 50 plus x whole cube. 64 cube. So because it's a 3-digit number, tens place can be from 1 to 9. Here also tens place can be from 1 to 9. 9 plus 9, 18. Idea clear, right? Easy if you know it. How many 3-digit numbers on cubing? How many 3-digit numbers on cubing? Gives 28 as the last 2 digits. It is 8. Smallest number is 2 cube 8. Next is 12 cube. 12 cube is 1728. If it is 12, next number will be 62 cube. How many 3-digit numbers? Same thing. 112 to 912 are 162 to 962. Total 9 plus 9, 18 numbers. Idea clear? Very easy question if you know this logic. How many 3-digit number? Tens place can be from 1 to 9 on cubing. I hope the idea is clear. What is the concept that I used? X cube 50 plus x whole cube has same last 2 digits. Has same last 2 digits. This problem and the previous problem, right? I hope it is clear. What are the concepts that we discussed? X cube 50 plus x whole cube has same last 2 digits, x as even. These two problems. Then x square minus y square has k, has integral solutions only when k is divisible by 4 or k is an odd number. Question. Next one. How to make a quadratic expression into a square minus b square by multiplying by 4. How to check whether the answer is right or wrong using multiple methods. Usage of prime numbers in a perfect square. Usage of prime numbers. 4th power is nothing but a perfect square. 6th power is derived from perfect cube logic. Beautiful question. How to play around with the unit digit numbers. X power y is a perfect square under what conditions, right? How to check whether the 3-digit number is a perfect square if you remove units place and the leftmost place. Armstrong number, digital sum. A perfect square will always be of the form 4p plus 2 or 4p plus, will never be of the form 4p plus 2, 4p plus 3. How to find out the numbers? I hope the idea is clear. Many examples that we have taken on the